Yes, so I'm back. I hope now it should work. Now it should work better. So we put 100% microphone working, and the loud should be really everything in the system working perfectly. So okay, good. That is wonderful. Okay, if there are some issues, yes, we will work out on that. And please, I do recommend to use earphones. In this case, it's really the sound will be better. So let us continue. So basically, the World Health Organization determines some certain hormones, definitely steroids, as examples of hormones, and cytotoxins as hazardous substances with which these requirements are applied. The areas to which this principle applies includes all zones where the handling of products could lead to cross-contamination. What does cross-contamination mean? So cross-contamination means that if one substance being contaminated by another substance, for example, or if one process is being contaminated by another process because of their leftovers being not cleaned on the previous process, or like that, when we have contamination, pollution of one substance by another. Exposure of personal or discharge to the environment. So what does it mean, discharge to the environment? Discharge to the environment means then their particular hazardous substance is released to the outside. Where possible, products that contain hazardous substances should be manufactured in closed systems. So when you see this attention sign, that means this question is for self-inspection and for actualization. So what are the cytotoxins? Please provide me an example. What are the an example of cytotoxin? Okay, please write me a message. What the example of cytotoxin we can show? So what is that? In that case, I see, yeah, good. Cancer agent, yes. What's something more? More variants? What's more? For example, some antibiotics, yes, something that kills cells, that may cause damage, yes, antiviral preparates. But viruses, they are not cellular organisms, so we cannot exactly name it as so said that this is cytotoxins that influence viruses, but definitely this all agents that cause damage to the cell. And what is closed system? How do you think? What is closed system? Yeah, good. Everything killing cells. That is a good answer. And what is closed system? How do you think? What is closed system? So closed system is the system where all the processes are being handled inside. It's for example, it's a clean room when all the operations are located inside. Nothing goes outside. So in that case, closed system definitely should be applied. Yes, there is no discharge. Should be applied when we work with their hazardous substances. So facilities should be designed and operated in accordance with the main GMP principles, good manufacturing practice principles. So what these principles include? To ensure quality of a product, definitely when we work, we want that the quality of our product was the best, yes, and therefore we need to apply for some principles that ensure that our quality will be at the highest level. To protect the operators from possible harmful effect of products containing hazardous substances. We also should care about workers that conduct operations with the hazardous substances. Hazardous means toxic, yes, something that can damage our health. To protect the environment from contamination and thereby protect the public from good. Harmful is the same as hazardous. Protect the public from possible harmful effects of products containing hazardous substances. So again, question for you. Give me a few examples, okay, maybe according to your experience, what are the hazardous substances generally used at pharmaceutical industry? What's the substance we can call hazardous, toxic, harmful? So what it could be? Any variants? So, for example, mercury-containing substances, definitely they possess high level of toxicity. Some substances that we say they can have really very bad influence, harmful influence to the health of workers. Okay? The production of certain products containing hazardous substances should generally be conducted in separated, dedicated, and self-contained facilities. What means separate? They should be located opposite from one to another. Everything should be located inside. Dedicated means the specific operations being conducted only in these facilities, only in these premises, because these facilities being constructed and also especially that this operation should be conducted only in this particular spaces, this particular room. Self-contained means same as closed facility, as we discussed a little bit earlier. So everything on which we are working is located inside. We do not allow anything to release outside. These self-contained facilities may be in the same building as another facility, but should be separated by a physical barrier and have, for example, separate entrances, staff facilities, and air handling systems. Definitely, that should support the good work while we are working with different substances. The extent of the separation from adjacent facilities and sharing of common services should be determined by risk assessment. If depending on the toxicity of the hazardousness of a substance, we should conduct the risk assessment. I think we have a question. Okay. Yeah, but let's say, okay, please remember your question, and we will discuss all the questions in the end of the webinar. Okay. Okay. So these manufacturing facilities should be regarded as containment facilities. So this everything that is located inside should stay inside. This means that containment facility. Operation of closed facilities. Effective aspects of effective handling of containment premises includes definitely appropriate facility design and layout with the emphasis on safely containing the materials that are being handled. So definitely the facility design should be in that way that supports the most safe conducting of all the operations that been done in this facility with the hazardous substance. Manufacturing process using closed system or barrier technology enhance operator and product protection. So layout means plan, everything, the scheme of their facility. A manufacturing process controls including adherence to standard operating procedures. Definitely we need to have standard operating procedures according to which we conduct all the operations. Appropriately designed environmental control systems, ACS, or heating, ventilation, air conditioning systems. So this is an explanation of HVAC. I hope we are more familiar with term HVAC than ACS, but in more health documentation, there is sometimes they make it equal, as HCS means HVAC. Design and layout is actually the same. This actually synonym. So layout means the arrangement of their premises, rooms, equipment, mostly rooms in the particular building. So that means the layout. Actually, the scheme of the building, it means layout. Move on. So operation of closed facilities definitely includes availability of extraction systems, application of personal protective equipment, because we talk about hazardous substances, appropriate degauning and decontamination procedures. What means degauning? So the procedures that tell us what appropriate gowning we need to wear while working with, in particular, classes of cleanliness, and what appropriate protective clothes we need to have. Decontamination. What does mean decontamination? Okay, please provide me please the explanation. In that case, I will see whether you understand what we are talking here, or that I need to explain some terms a little bit better. So what does it? Yeah, removal of contaminants. Very good. So its synonym is cleaning. Good, thank you. Industrial hygiene. What does industrial hygiene? What does it mean? So monitoring staff exposure levels, medical surveillance. Again, monitoring staff exposure levels means in their aspect with the focus on the health of workers, because medical surveillance means checkups with doctors, administrative controls. Now, please provide me an answer. What does industrial hygiene include? At least one example. What does industrial hygiene include? At least one example. So what it could be? Premises cleaning. Good. Yes. Using appropriate clothes when we work in appropriate classes when we work in different classes of cleanliness. Yes. Determining the standard operation procedures when we work in different premises, and much more. Okay. Now let's determine some particular terms that mostly we use today and we can find on the normative documents. So glossary. Glossary means vocabulary. So action limit. What is action limit? Action limit is reached when the acceptance criteria of a critical parameter have been exceeded. So when our results exceed the acceptance criteria to this index. Results outside these limits will require specified action and investigation. Yes, so when we reach the action limit, definitely some actions need to be applied for reducing the risk and reducing this data. Okay, I will answer this. Межаді. This is a Ukrainian variant for action limit. Airlock. Airlock is an enclosed space with two or more doors, which is interposed between two or more rooms, for example, of different classes of cleanliness for the purpose of controlling the airflow between those rooms when they need to be entered. So airlock can be actually for material or for personal. Therefore we call it personal airlock or material airlock. Alert limit is a little bit different. It's that action limit because the alert limit is reached when the normal operating range of a critical parameter has been exceeded, indicating that corrective measures may need to be taken to prevent the action limit being reached. Yes, so when we have alert limit, we see that our results are on the edge with the critical parameter. So this the data is almost critical. So if we will not apply some specific preventive actions, we may have the action limit. So it's межа тривоги, Ukrainian variant. Barrier technology. System for segregation of people from the products that contain contaminants, or for segregation of two areas. Actually, barrier technologies can be of different types. There is a barrier isolator or restricted access barrier system. Actually, a restricted access barrier system sometimes includes into a barrier isolator. What is the difference? A barrier isolator, we can come inside this system and work there. And when we talk about restricted access barrier systems, it's more we talk about that particular isolators where we can put only our hands with the specific laws there, and the operation are being conducted in this way. So this there you see an images, figure 1 and figure 2, where there are particular examples of barrier isolator and restricted access barrier system. Okay, containment. Containment means it's not contamination. Yes, containment means that everything is operation, process, device, dust, and contaminants remains in one zone, preventing it from escaping to another zone. Facility is a building or some specific establishment where the operation being handled. Hazardous substance or product is actually some toxic substance or product about which we are talking. Normal operating range. The range that the manufacturer selects as the acceptable values for a parameter during normal operation. This range must be within the operating range. Yes, so it's like the range for particular parameter in which we know that is okay and that is applies to the normative requirements. Okay, personal protective equipment. The necessary garment and equipment required to protect the operator in the workplace. Unidirectional airflow is the rectified. It means the one direction of this airflow that cross the entire cross-sectional area of clean zone. It has steady velocity, means permanent speed. Yes, velocity means speed, steady, like permanent stable speed, and approximately parallel streamlines. Validation. What is validation? It's a documented act of proving that any procedure, process, equipment, material, activity, or system actually leads to the expected result. With validation, we show that our process is reliable, our data are trustful, and this process is working absolutely fine and give us trusted data. Occupational exposure level, actually very important when we talk about hazardous substances. This is the airborne concentration of substances that will not result in adverse means harmful, dangerous effects to most healthy workers exposed for 8 hours per day, 40 hours per week. Let's talk now about risk assessment of substance toxicity. So risk assessment should be carried out to determine the potential hazards of the substance to operators and to the environment. The risk assessment includes it's devoted to specific processes, specific phases of the product production and control cycles, with which we can see what the phases possess higher risk or lower risk, depending on our process, depending on the influence to the operators and to the influence on the environment. Risk assessment of environmental contamination should include airborne contamination as well as liquid effluent contamination. And effluent means wastewater. So we talk about liquid wastewater contamination. Risk assessment should take into account the national, international occupational health and safety requirements for permissible occupational exposure levels for the product in the work environment. So risk means actually the combination of the probability of an event and the consequence in case this event happens. Yes, so the reason and the result. Risk assessment is the overall process of risk analysis and risk evaluation. Actually, with the risk assessment, we want to see all the negative consequences that we can get in various situations. So, risk management process by who has such scheme that we will discuss more in the full version of the webinar, not today. So, the basic approach for risk assessment of substance hazardousness can include such a simple formula with which we can determine this is a very basic general approach to determining the hazardous of the substances. So with this approach, we multiply 4 factors. So risk from hazardous substance effect is the multiplication of A, level of substance toxicity, that is determined from specific standards in which there are determined hazardousness of different substances, and depending on the influence of the health of the workers. B, ease of substance dispersion and transfer. C, contact of the staff with the hazardous substance while operations. And D, effectiveness of precautions and barrier technology. So how it works? We have such table. For example, let's take the non-toxic, completely non-toxic substance. For example, let it be glucose. Yes, it's not toxic. So we see level of substance toxicity. So it's 0. Yes, we have 0. Here, ease of dispersion and transfer the hazardous substances, very low, so it will be 0.5. Contact of the staff with the hazardous substance while operation. Let's take, for example, if we have an automatic process, so contact under necessity, for example, if machine breakdown and if our cleaning is not automatic, so it's cleaning. And effectiveness of precautions and barrier technology. Let's say that our barrier technology, they provide very good protection. So we multiply 0 on 0.5, on 1, and on 0.5 by this formula. Yes, we multiply, and again we got 0. Yes, so we have low risk. Operations with the substance do not pose a threat to operators. Let's take, for example, some hazardous substance. Okay, let's take, for example, mercury-containing powdery substance. So the level of substance toxicity is high. Yes, we take 2. Let's say ease of dispersion of transfer the hazardous substance is medium, 1.5. We assess that the ease of dispersion is medium, it's 1.5. Contact of the staff with the hazardous substance while operation is only under necessity, so it's 1. And let's say that our barrier technology working fine and provide, again, very good protection. So we will multiply 2 on 1.5. We have 3 on 1. We have 3 and 0.5. If you say that we have good protection, we have 3. And so we calculate that according to our SS, we have this basic while applications, this basic approach, we have medium risk. Operation with the substance may cause a harmful influence to operators, but work is permitted as long as all the manipulations are carried out in compliance with the regulatory documents. So this is like the basic approach for risk assessment. There are also exist different other risk assessment risk approaches for risk assessments of substance hazardousness, but we will also discuss it on the full version of the webinar. So now we move on to personal protection equipment and breathing air systems. Operators should be protected from toxic exposure of hazardous materials by wearing high-density polyethylene fiber material suits. That suits should not contain any organics, because in that case they may be an additional pollutant in the clean rooms. Or impervious means integral, washable protective suit shoes, lower leg covers, or cleanable boots. So it can be seen on the figure 3. Integral hoods may be required depending on the respirator type that is used. Suitable, so suitable means appropriate. Single-use disposable gloves, definitely depending on the operation. Double gloves should be worn when where direct active contact with the product cannot be avoided. So respirator, eye and face protection with associated breathing air systems. Definitely depending on our risk assessment, on our operation, toxicity of the substance, class of cleanliness and other factors, there is appropriate degowning procedures, appropriate costume, and this industrial suit that we should work for conducting these operations. Okay, personal protection equipment, breathing air system. So let's talk about a little bit about air supply and the particular air respirators. So under application of breathing air systems, the safe breathing air should be provided to the operators. Yes, so this is like the basic scheme of the system of air supply and changeover. This while providing such air, that means that operators is protected from inhaling the air that may contain particles of hazardous substances that may cause really very dangerous effect on the personal health. The breathing air system should include a protective face mask, which form an integral part of a protective suit. So there exist various types of breathing air systems. Today we will discuss 3 of them. So first is an airline respirator. That is it has a central air supply system that you could see on the previous slide. So it connects to the operator face mask by means of flexible hoses and quick coupling sockets. So it's actually, this is not dynamic system. This is located in one area and is completely automatic. The air supply should be treated to ensure a temperature and level of humidity that are comfortable for the operator. Definitely, these parameters need to be controlled because this air is being inhaled by the person who works in this premise with a hazardous substance. Another type is of breathing air system is self-containing breathing apparatus or powered air purifying respirator, SPIE or APR. So it's securely attached to the operator's belt and connects to the operator face mask. So actually it's more movable. It's not being located, there is no necessity for it to be located in one place. So the operator can put the balloons on his back, as you can see on the figure, and then so in that case the breathing can be done with this safe air that is located in this balloon. So that can be applied for the substances with a lower level of toxicity, for working with substances with lower level of toxicity in comparison with the previous equipment. Okay, and when we talk about lower hazardous substances, we may use only a half mask with high efficiency particulate air filter, cartridge that have cartridge respirator, or N95 type paper filter mask. N95 means that the effectiveness of not allowing the particles, so filtration, the particles is 95% except oil particles. It's not working for oil particles. So it does not require any additional electronic supply. So central breathing air supply system should have definitely a 1% backup system while the main system falling. So it could be in the form of gas bottle system with at least 5 minutes supply. Yes, definitely if there are some breakdowns of the system, because for avoiding of suffocation of the personnel, we should have a reserve backup system that will work minimum for 5 minutes under any breakdown of the system. Changeover from the normal supply to the backup supply should be definitely automatic. In other cases, it can be very dangerous for the personnel. System should have a monitoring system and send alarm to signals to a permanently monitoring location. That is also very important in the following situation: when there is a failure of main air supply, temperature is out of specification, humidity means the content of water in the air. Yes, this is humidity. The gas content of this air is not appropriate. So, for example, the combination carbon dioxide, carbon monoxide, sulfur dioxide, other gases that are inside this air. Where air is delivered through a central system, the piping should not cause any contamination. Yes, therefore, it's recommended to use stainless steel piping because it's not liberate the particles that can have the adverse harmful effects on the operators. So, due to the hazardous nature of the product being handled in the facility, neither the product nor its residues should be allowed to escape into the atmosphere, definitely, because it can have a dangerous, very harmful effect to the environment. Yes, they also should not be discharged directly to normal drainage system. The actual atmosphere and the public in the vicinity, so it means in the nearby territories of the facility, should be protected from possible harm from hazardous substances. If liquid effluent possess a safety or possess a contamination risk, the effluent should be treated before being discharged to a municipal drain. Yes. So the question for you: how hazardous substance could affect the surrounding environment? So please give at least one example. I want to see how well we understand, how well there is whether there's I need to explain something more. So how hazardous substance could affect the surrounding environment? Please one example. Yes, contamination of groundwater, definitely. Some contamination, okay, acidifying of grounds. Yes, so yes, waste water. They could cause contamination of water, grounds. That can have really very deleterious, very adverse effect on our atmosphere, and therefore we need to be very careful while working with the hazardous substances and allowing it to escape into the environment. What about facility layout? Yes, there was a question about layout, the facility scheme, facility plan. The premises where the work with the hazardous product is carried should be definitely designed and constructed to prevent the ingress, means intake, or egress of contaminants, or means that releasing of contaminants. The link between the interior and exterior of the premises should definitely be made with the airlock. So this is the we have different with the airlock or pass boxes, pass-through hatches. So we have an example of pass box, pass-through hatch on the figure 9. And with earlier we discussed a little bit personal airlocks and material. What is personal airlock or material airlock? When there are specific enclosed space through which the material is being transferred, or personnel can enter the rooms with a different level of cleanliness. The premises and equipment should be appropriately designed and installed to facilitate cleaning and decontamination. Okay, again, question for you: does the containment means that everything is located inside, the system is closed? Does the containment of premises where hazardous substances are maintained is obligatory? So only requires one answer, yes or no. So, that the containment of premises where hazardous substances are maintained is obligatory. How do you think? Yes, good. That is the right answer. Definitely. If we would talk about hazardous substances, all the operations need to be done in the containment facilities, and nothing can be allowed to discharge to the environment or to another facilities, because it not only can lead to cross-contamination, but also can have very toxic influence on the person. Okay, let's move on. So on the screen now you see the basic layout of the facility. It's just a general example. So the main, you see that the yellow parts, this is grade B, the green part is grade B, and the blue part is grade C. We see that the level of cleanliness increase while we walk inside this facility. Yes. So for the class D is surrounded by surrounds the class C, and class C surrounds class B. So in that case, we have appropriate facility design. This also we will discuss more on the full version of the webinar. Air handling system. What about air handling system? The main thing about air handling system is where the processes with high level of cleanliness, these processes need to be conducted under more negative pressure according to the processes with the less level of cleanness. You see, the primary packaging is under more negative pressure according to secondary packaging. So, basic air handling characteristics of facilities and premises that dealing with hazardous substances include, first, air conditioning and ventilation should be under the, as we said, negative pressure related to the outside, for not allowing to escaping the hazardous substances to the environment. Uncontrolled flow of air between the work area and the external environment, or direct venting of air to the outside, is strictly prohibited. Yes, because we talk all the time about containment facilities. Visual indication of the status of room pressures should be provided in each room. Air should be exhausted to the outside through HEPA filters and not recirculated. Yet, further HEPA filtration stage is applied to the return air. Okay. Where possible, single-pass air handling systems with no recirculation should be provided. And again, question for you. What are the risks, in your opinion, what are the risks of recirculation of exhausted air? So what the risk can have the recirculation of exhausted air? I'm waiting for your answers. Okay, at least one example. Contamination, yes, additional contamination of air, yes, has a toxic influence to the personnel, yes, because personnel if there is not set classes where respirator air systems are applied, and there is recirculation of air even not in clean zones, or for example in that locations where the work with less toxic substances being carried out, so we can have a high risk to the personal health, to our processes, it can lead to cross-contamination. So actually this is not a good idea, yes, to have the circulation of exhausted air. Okay, this is a basic image of some also general image of the clean room pressure indicator that show us the pressure between rooms in which where different operations being handled. So with this we can see whether we have the negative pressure, whether the pressure is within the normal operating range. Is there any alert or action limit arise? And with this gadgets we can control our operations. Okay, so this is also the general basic scheme of allocation of filters. So 2 banks of HEPA filters in series should be considered to provide additional protection if the first filter fails to exhaust systems where the discharge contaminant is considered particularly hazardous. Yes, definitely we need to have some backup filters. So this is like the basic scheme for location of filters. Actually, filters have been changed with is a procedure that's called back-in, back-out system, back-in, back-out process. That also we will discuss more on we will discuss detailed on the full version of the webinar. Safe change filter housing so includes all filter banks should be provided with pressure differential indication gauges. Yes, definitely to control the filter overloading and remaining lifespan of the filters. Connections to these gauges should be gauge mean device. Yes, so it means that device that show us the pressure. Connection to these gauges should be copper or stainless steel, and definitely not plastic tubing that could perish, that could damage, causing a contamination hazard. Monitoring of filters should be done at regular intervals to prevent excessive filter loading. Yes, if you have excessive filter loading, so definitely it can also have a risk to our process and to all our operations. That could actually to prevent excessive filter loading that could force dust particles to the filter media or could cause a filter to burst. Yes, filter just will break down, resulting in ambient big concentration. All exhaust points outside the building should be located as far as possible from air entry points. An exit point should be at a high level to minimize the possibility of reentrayment of exhaust air. Records of the safe disposal of all contaminated filters and dust definitely should be kept to see how it's used. Is there higher level of contamination or lower, and how there also operations of the hazardous substance being done. Again, question for you: should alert and action limits be determined for filter overloading? Should we need to determine the alert and action limits for filter overloading? Again, only one word for answer: yes or no. Yes, good. Yes, it definitely should, because if we will not know this alert and action limits, in that case we will not understand whether our system is working properly, is there any problem, is our filtration is efficient, and if our process is really under control. Okay, personal decontamination systems. When we talk about hazardous substances, and actually lots of them are in a powdery form, we need to have specific equipment to use to overcome the contamination while we have disposable, while we need to throw away our working garment. So if required, a means of preventing contaminants from leaving the facility, yes, on the personal garment, this specific means should be provided. This could be in the form of an air shower, yes, when we provide air to eliminate the particles from the costume, or mist shower. So appropriate water shower, mist shower, or fog shower that could cause the adherence of the particles on the surface of the costume, and therefore they will not be able to liberate into the environment, and they, because of their adhesions, then can be easily thrown away. So here on the figure 15, you can see that means the decontamination system and a shower, some basic particular examples. Effluent treatment. Also, the general scheme of effluent treatment, definitely liquid and solid waste effluent should be handled in a way as not to present risk to their of contamination to the product, personal, or to the environment. All effluents should be disposed in a safe manner, and the means of disposal should be documented. So the basic scheme includes a collection system, screening, grit removal, primary sedimentation. Okay, so then we have more advanced cleaning, more advanced treatment. It's aeration, secondary settling, filtration. Then we can apply chlorine for secondary effluent, and in that case we have the secondary. In that process we have the secondary effluent that again can be treated and may be reused in some process. So let us summarize what we have, what we discussed today, and with what we get acquainted today. So hazardous substances that pharmaceutical products may contain, determined by the World Health Organization, include certain steroids, especially this makes the accent on steroids, hormones, and cytotoxics. Operations with hazardous substances should be carried out in closed, means contained facilities with appropriate layout and HVAC systems functioning. Risk assessments need to be applied for determination of the toxicity of respective substance and its potential hazards. Manipulation with hazardous substances and its waste material should not pose a threat. It should not have a risk to the environment, personal, public, or lead to cross-contamination. The respective type of breathing air system is obligatory in dependence on the level of the substance toxicity. Yes, depending on which substance we work with, on its level of toxicity, we need to apply respective air breathing system for having appropriate protection of ourselves while working with that. Yes, adherence to the standard operating procedures supports effective, safe, and qualitative performance of the operations. So here you can find the basic word list for all these terms that has been applied in this presentation. There, in that case, maybe if there was some not sufficient understanding, so you can find all the terms here. Okay, and thanks a lot for your attention. It was very nice to give this webinar to you today. If you have any questions, please write it down, and I will provide an answer to that. Thanks a lot for your attention.